Alrighty, so this is the first video in the electricity and magnetism playlist. We are going to be following a first year university course. It's not going to be the exact same, but hopefully I'll cover enough content to give you a better grasp on the subject. To start, we have electric charges. Now, what are they? So see this green circle? This circle is going to represent a proton, and this red circle is going to represent an electron. Electrons have negative charges, protons have positive charges. So it is from these protons and electrons that we get our charges. We denote this charge by the letter Q, and the charge is equal to plus or minus Ne. So N is an integer, so that could be like 5 or 6. It's like how many do we have? And then E is the charge on one proton or one electron. The reason why it could be plus or minus is because protons are positive, electrons are negative, but they both have the same amount of charge, just opposite signs. So the charge on one proton is equal to 1.6 times 10 to the negative 19 coulombs. So it is tiny. It's absolutely tiny. And this coulombs is equal to the charge on 6.25 times 10 to the 18 protons. The reason this number is so huge is because the charge on one proton or one electron is so small that we usually have a whole bunch of them at once. So there are a few ways in which you can charge objects. The first one is charging by friction. This purplish circle that I drew contains one electron and one proton, just for simplicity. Now, let's say that we are rubbing it together with something. So it's like a balloon on your hair. And eventually it's going to break. So this is super simplified. But eventually we're left with one part that is negative and one part that is positive. The total charge stays the same. We're not creating anything, but we're breaking the bonds between them. So it's like we're slicing this in half and they're going their separate ways. So ions are created. Again, this is super simplified. It's not actually what anything looks like. Now again, just like the conservation of mass, the conservation of charge exists as well, because nothing is created and nothing is destroyed. So this is a summation sign, because the sum of the initial charge is equal to the sum of the final charge. The charge is equal to the number of protons minus the number of electrons multiplied by the charge. So if we have 16 protons and we have 5 electrons, we do 16 minus 5 and multiplied by the charge on each of those individual protons. Now there's a difference between insulators and conductors. Maybe you've heard about some before, like conductors as in some metals, or insulators like rubber. Now the first part is that in insulators, electrons are tightly bound at the center. They are immobile. Here we have an insulator, let's say it's a rubber ball, and we have our electrons that are super tightly bound around the center. They're not moving much. Now the opposite is a conductor, where we have our valence electrons that move around freely, and eventually they're just going to make their way around the outside of this object. So if it's a metal ball, the charges are all going to be on the outside. So there's going to be a net force on the surface. Now polarization. Polarization is when the net charge is 0, but there's one side of the object that's more positive than the other. Let's take this stick. It's a stick with a lot of negative charge, and we're going to put it really close to this metal box that has positive charges and negative charges. What's going to happen is that the positive charges are going to be attracted to these negative charges. and then these negative charges are going to be repelled by them. Again, this is really simplified. Charges don't just float around like this, but the main idea is that there's going to be a net force that is pointing this way, and that is going towards this negative block. And here there's still a force because these little electrons are trying to get away, but they're not as strong as this force. This is what we call polarization. So this box, this square, has been polarized. Now what about insulators? Remember that insulators, they're tightly bound around the center of our object. So if here we have an atom has protons and neutrons at the center, and they have electrons on the outside. Let's say we have 3 atoms. These 3 atoms are super tightly bound in this circle. This is a rubber circle, let's say. These can still be polarized because what happens is, in the atoms themselves, the electrons are still going to be attracted to this huge green positive force. So it's like we're stretching our atom a little bit, and one of the charges goes to one side and the other goes to the other because our protons are being pushed away because they do not like hanging out with protons. Now the last thing is charging by induction. This is when we charge an object without touching it. Here, this is an example from a textbook. We have an ebonite rod. So we have a rod that's super negative, and we have a metal sphere. Because this metal sphere is a conductor, the charge is all along the surface. Now what's going to happen is the positive charges are going to be attracted by this negative rod. So see, the positives are on this side and the negatives are down here. Well, eventually they're going to be completely separated, and what we do is we attach a grounding wire, and it's basically just a wire that's going to allow the electrons to escape. So we have our protons that are still being attracted, our electrons escape, and then when we move this rod away, we're just left with a positively charged ball. That is it for charges. Hopefully it made sense. And the next little video is going to be on Coulomb's law and how we can use that.